Okay, here we are again.
Okay. Do you still see the screen
Perfect.
on the right screen? Am I not showing the Zoom
Yeah,
meeting?
yeah, yeah, I see perfectly. Your screen is shared.
Perfect. Yeah.
Perfectly. Thank you. Thank you, and sorry again.
Yeah, no problem. So, as we were saying, do we have everyone first? Let's check if we have everyone,
Uh,
if we missing
Almost.
some.
We might lost one or two, but they're gonna probably join us
Okay,
quickly. So keep going. That's fine.
perfect. So as I was saying, artificial intelligence methods are basically methods that can mimic the human intuition or the human the decision-making abilities, and not all of them are strongly reliant on data, even though most of them are. Let's just find a few examples of non-data reliant artificial intelligence. Um, you might have heard about the Deep Blue chessbot, the first chessbot to beat the chess world champion, was actually um, not based on any data. It was like every instruction it could give, every move it could give was programmed um, through what we call a decision tree. So, like, it was seeing a variety of possibility, and it was deciding among them just to going quickly. Now, one thing that is a bit more practical, every not every, but a lot of time optimization or task planification um, software that could be considered artificial intelligence in that in the organizational management part of intelligence would not necessarily require data either. Now, for those who need it, that's the one we call machine learning methods. And still, to remain general, the idea of machine learning is to have a model, a program, but that has parameters. It has parameters like buttons you can tweak, and you are going to tweak that model, right, using data. So you have to simplify input and output data, and by tweaking the model the right way, automatically, of course, that's the point of machine learning, you're going to be able to have a model that does what you want. And deep learning, which is most of the time what is behind the technology behind what we call artificial intelligence today, is just machine learning using a specific kind of model called a neural network. Um, so it is a bit peculiar in that it has a training phase that is common to most machine learning methods, but is especially important in deep learning, as it is really much more computationally intensive. So the idea behind it is to have that neural network that you see those little connections, which is a lot of very simple operation, but there are so many simple operations that you can get very complex stuff. And as I said, training is an input, an output, and you may succeed or fail, you get an error, and with that error, you can learn, and iteratively on a cycle, that is um, how deep learning methods are trained. Then once that is done, you can do what the step of inference, that is just using the method, which is much less computational intensive, and that's one of the key interests of the deep learning methods. So machine learning methods, it applies to deep learning, even though it would also apply to any other machine learning methods. Uh, it's especially useful when you as a person, when the person is really able to take the decision intuitively but it would be really hard to explain to a machine what it is. And of course, it's machine learning methods that's really data driven. So the best kind of data you can have, the more data you can have, the easier it's going to be to solve the problem. On the other hand, machine learning, when there is little to no available data, it gets a lot harder to make good use of machine learning methods. Other thing that sometimes you want to have a proof that it works. You want your solution to be the best possible solution, given certain hypothesis. In that case, machine learning methods are not for you, because as data-driven methods, you cannot get a mathematically proof that the data you use is the perfect data for your case. And that is also because of another thing that is really common and really well known with machine learning methods, and especially deep learning methods, which were called bias. Let's take that example. We just need, for whatever reason, to split a deck of cards, to split the cards that we see into two groups. We do not know, like the machine will not have the intuition of what is the logic behind it. So you just have the data. These are the cards on the group 1, these are the cards on the group 2. Now is my question. Maybe you see it come. What about this card? Which group would it be in? Well, maybe it should be in group 1 because it's a face card. Maybe it should be in group 2 because it's a black card. That is what we call biased data. So there's the feature you want in your classification, but there's also underlying features that you don't really know what they are. You don't really know what they are, and machine can also learn to make those discrimination based on underlying features. When it's not about cards, but about something a bit more sensitive, you can imagine that you need to be aware of those problems in your data before you put your machine learning method into use. But that is a known problem. So it's something you need to do, but something that can be done most of the time. Then when you go into really artificial intelligence methods, like something that can have an impact on people's life, you might have ethical and moral consideration to take into consideration. For example, if you take autonomous vehicle, you might get into a situation where either the driver or a pedestrian might get hurt. On a driving car, the driver is going to act as a reflex, but maybe in artificial intelligence we have the time to take a full decision. What is the decision we want to take in that case? I'm sorry, I do not have an answer for that one, but those questions might arise with artificial intelligence methods. One last thing, in general, if you want to apply artificial intelligence, is what you can trust it for. When you think about generative AI, so generative AIs are the ones that can produce text like ChatGPT, like those ones, or images. Those are called generative AI, as they can generate new-ish stuff. As of now, it can be efficient in assisting people who already know what they're talking about, but you can't just give one of those AI in the hands of someone who has no idea what they're doing and hope it turns for the best. It is very unlikely to happen. Other kind of AI, working case by case. So it will really depend on what you do with them. And finally, if you decide to have a company that is putting AI forward, there are going to be interrogation from your customers, from the public, and privacy questions that you also need to be prepared for. Unfortunately, this is really case dependent, and I cannot really provide the solution for you. Okay, so once you have decided that you need to implement AI for a part of your business model, that is what you need to have: computing resources, data, and methods. But let's just get rid of some stereotypes. First, you will not need terabytes of data, in that even with relatively small amount of data, you can kickstart some artificial intelligence methods. You won't necessarily need a supercomputer like we have in house, although it was often depend on your case. The most important thing, AI is very unlikely to replace your experts. As like, well, if it's something that just any AI can do, like, you will still need an expertise of someone to make sure it goes on the right way. So all of those four parts, like, are just preconceptions that you need to get rid of before starting. So here is how you loop through an AI project. So the first thing you need to do is, like any product, you need to understand your problem. What is it that you need to solve? What will you give your AI, and what do you expect from it? Then, more often than not, unless you are in the very few cases that we are at the start, where you do not really need to collect data, you will need to collect data. That is something, when you have a business, something that can be actually done with a set of good habits to collect, organize, and analyze the data that you have. First, so the collection is, where's the data? Can it be found outside, open or for a price, or can you collect it inside your own company? Whose is it, and are you allowed to use it? Those are two different questions, because it's not because the data is yours that you are allowed to use it. For example, if it's your customer data, you're the one who got it, but there are a lot of different privacy laws, especially in the European Union, that you need to take into account before going ahead and using that data. And also, is it complete? Are there parts missing? If it is, what do you do about it? And can it be trusted? Is the data you get reliable? It might not always get the case. All those parts are about understanding the data. You collect the data, then you need to understand it. And then it gets in the most technical part, where you find the right structure for the data, for it to be easily accessible, to have the right way to train the methods. And then you can go into the method themselves. That's the modelization part. So you find a method that can be tuned with your data to get the result that you want. And then finally, you get into the evaluation and take the decision into whether it is ready for production, or if you have to get through another loop before you can properly offer it to your public. And I've talked about a lot of data because it's the most essential part, so much so that there are actually different different expertise that can be had with data. It's not just managing data can mean a lot of things. From managing the structures themselves or the governance of the data to visualize the kind of data that you have. That might also be a requirement. On to finally on the more algorithmic part, where you design the methods or adapt existing methods for your case. So that is going to conclude my presentation. And if you have any question, I will gladly try to answer them to the best of my abilities.
Thank you, Theo, for the presentation. Is there any question on the room, or everything is clear? Okay, perfect. So let's move on to the yes. Sorry, I didn't see Suleiman. Yes, Suleiman, go on.
Thank you very much for the presentation. I would love to ask, what is the best way to learn artificial intelligence from zero? For us, for example, I'm a medical doctor and I have no experience with artificial intelligence. Maybe the speaker can advise me something about learning this, as it is really important for the future in my field, my field as a medical doctor.
Okay, so you mean learning artificial intelligence in a technical point, or you mean in like a more overview and project management point?
Both of them, in fact.
Okay. So on the technical point, you have quite a few options. I do not know if, like, in your own university, you have teachers that could possibly make things for you, but in resources, you have resources online, both free and premium, that can help you. The one on top of my mind, on the free one, would be Kaggle has some courses to get started with deep learning. So it will be on the, when I say technical thing, it will be like programming. You are mostly expected to have a basic understanding of programming, and hopefully the language, that the programming language that they're going to use. For deep learning, it's most of the time Python for a machine. For a premium, you have NVIDIA, who offers a lot of classes also. But of course, that are also going to be a bit oriented towards their own tools. But the very basic ones are very general.
Okay. May I add something?
Yeah, sure. Go ahead.
Yeah, thanks. I think there are, Sulaiman, I can send you, there are several tutorials. I think it's very important to have, to be able to write short program in Python. If you don't know Python, you cannot program anything. This is the first step. But you don't need to be expert in Python. What you need to do is just to be able to understand, because today most, ChatGPT or any generative AI is able to help you to write any program. But then it's very important to understand this program, because sometimes the program is not suitable, for example, for your data, or for example, it doesn't, for example, say that, okay, you have to, for example, your data must be normalized, must be, there are very, very several steps, for example, to prepare your data. Okay, Theo has explained some of them. But I think the best way, first, to learn Python, okay, and this is not difficult. With few hours, you are able to write a Python program. Then there are several tutorials. There is some websites, for example. I am using this with my students, for example. Neural networks for beginners, deep learnings for, I can send you the link, okay? Or if you want to be really expert in the domain, I think you have to, there are all these tutorials, online tutorials that take maybe, 20 hours or something like this, but by the end you are experts. Because they explain, for example, what are all the steps you have to follow to explain those steps, but they go in details, okay? How to, for example, to build your data set. This is a very, very important step. But you can first say, okay, I use any data set. For example, just go to Kaggle if you are in medical field, and put few keywords, and you will get your data set. And you will also get the code, okay, in Kaggle, for example. But still, if you are not, for example, if I know you haven't already installed the Python environment, if you don't have, okay, but it's not difficult, okay?
Yeah, thank you very much, Professor.
And I can send you some tutorial. I can give you my email by chat, okay?
Yeah, I would love to.
Okay,
Thank you very much.
you're welcome.
Okay, thank you, Zaya. Theo, you have a question. Do you consider AI is here for a long time, or will it crash in 4 to 5 years?
I consider that AI is going to be here for a long time. Maybe not in the form that we see it today, because I need to put words on what I have in mind, but there's a growing interest, there's a really strong interest right now, but it's still a technology that is going on the rise, which means that we are not certain how far it's going to go, how fast it's going to achieve what we need it to do. But also, we do not know yet the right way to improve what we already have. And from all the investment that are made right now, from all the ideas that we have, that okay, we can use AI for this, for that, for this, for that. Some of them are going to go nowhere. Some of them are going to be investment that are going to be a huge waste of resources. That's kind of how technology has evolved, kind of always. So the way we see it right now may not be the way it's going to be seeing it in 5, 10, 15 years. It's going to look different, seem different. But I think this is a technology that is going to is going to be more and more part of the personal and professional life.
And please, may I get something, add something? But I think it's very important to don't forget that AI is not only machine learning and deep learning. And for example, one challenges today is the scalability. And there are several techniques, for example, knowledge engineering and for example, case-based reasoning, all this symbolic AI, but also collective intelligence and lot of other topics. And today, for example, there is one important challenge people are addressing. All this, big companies, I don't give the names, are addressing is, for example, the scalability. And they are, for example, trying to combine deep learning with collective intelligence or multi-agent systems. So I think that, as I put in the chat, for example, yeah, AI is here since 1958, it's so old. It's not, AI is not only 10 years ago, and I think that a lot of things will converge to build, for example, when we speak about explainable AI, it's a hybrid AI that use both deep learning and symbolic AI to explain, is this black boxes? So there are a lot of challenges. So I think that we will see a lot of, how we say, new projects on AI and on machine learning and other techniques.
Thank you, Zaya. I think we're gonna have some answers from Frederic, who is gonna introduce Quantic or Quantic, right?
Yeah, can you
Hello,
hear me?
Frederic. Yes,
Yeah,
good.
good. Okay, I'm
You
gonna
can
share
go on.
my screen. Yeah.
Yeah, this is an important context when we can do a lot of things.
Can you see my screen?
Yeah,
Yes,
perfect.
Frederic.
Yeah, okay. So, hello everybody. So I'm Frederic Moguer, and I'm also a research engineer in the Romeo HPC Center in Reims University. So I'm gonna talk a little bit about quantum computing, giving you an overview of what quantum computing is. And okay. So the first question you may ask is, what is quantum computing? So you used to use traditional computers with the treatment of information based on zero and ones, and almost everything that has to know about this machinery. And some peoples, and especially the guy on the bottom, had some ideas and saying that maybe we could mimic what nature is doing, and what nature is doing computation with quantum mechanical objects. And that was quite the birth of quantum computing, with this little idea that maybe we can use this quantum mechanical objects to make computations. And what will change if we do that? What will be new? And will it be worth doing that? Do we gain something? And the answer is yes. So when you want to understand quantum computing, you have to enter the subject of quantum mechanics, which is quite a hard subject, a bit strange at first sight. So you have to get used to learn a little bit of physics before understanding what you're doing. but not very complicated things. The only things you have to, you have to admit that you will not understand everything with quantum mechanics. So why why we're putting so much efforts in trying to build quantum computers? So with quantum computers, there is a promise of a large speed of our calculations. So that's the first aim at putting so much efforts in trying to build quantum computers. And there are today's problems that we cannot solve with classical computers. The problems that takes too much time, that before starting, that it will take so much years to solve that it's not even worth trying. Maybe at some point we can address this kind of problems with the new quantum computers. So that's also a motivation for trying to build quantum computers, and also from the perspective of physicists, mathematicians, there's also a motivation about exploring, probing nature in a very deep functioning, and trying to understand, to put some explanation about the strange laws we discovered about quantum mechanics. When we talk about quantum computing, we're really talking about a multidisciplinary subject. There is, of course, the physicist involved in the story. That's the start of the very subject. There are also a whole branch of mathematics which is involved in this story. People's doing quantum informations, put a lot of efforts to understand how this strange new informations behaves. So that's a part of the subject. We need also computer scientists to help us put together the future quantum computers with the traditional HPC systems that we have. And if you want to finally build a quantum computer, you need a lot of engineers to accomplish some miracles in order to make this thing works. So where are we in the story of quantum computers? So we can identify almost three phases in the quantum computers story. There is a start which we locate at the early 80s with a paper by Feynman, Richard Feynman, a Nobel Prize in Physics, which started the first phase of discovery, what we call the discovery phase of quantum computing. And during this initial phase, people were struggling, were thinking a lot with a pencil and a paper, trying to figure out what we can do with when we replace traditional 0 and 1 to do computation with quantum objects, and trying to find interesting things and new behavior that will somehow show some improvement compared to what we do traditionally with classical computers. So we've been struggling for quite a long time, and but still no proper quantum computers up to 2019. And when I say proper quantum computer, I just say some prototypes with a few qubits where we're not able to do very interesting things. But at least we saw first systems emerging in 2019 that were able to demonstrate that we can use quantum mechanical objects to do computations, and we can use them to make things better than we can do with classical computers. So that started the second era of quantum computers, which we call noisy intermediate scale quantum computing, NISQ for the abbreviation. Noisy means that the system we've built are still subject to the environment noise. And that's quite critical for quantum computers to be well isolated. Otherwise, they will lose their quantum character, and that will destroy our computations. So we have to deal with noisy systems that are still full of errors, and we have to deal with these errors. And they are intermediate scale in the sense that in order to do interesting things, we need to put a lot of computing units. And in the case of quantum computers, it's the qubit that you surely have heard about. And there is a real challenge now to scale in number of qubits in order to make those quantum computers doing interesting things. When we'll solve all these problems, we'll hopefully enter a new era, which we call the fault-tolerant quantum computers. So I put a flag on 2030 something, but I don't have a real date to put here. It's just expert expectation that the project that they may have some interesting quantum computers by that time. And those quantum computers will deal with the errors, so that will make them fault tolerant, and they will solve also the scaling problem with a lot of qubits to do interesting things. So what's so exciting about quantum computing? So we know with classical computers how to process information, and especially binary information based on 0 and 1. And when we switch to quantum computing, we'll have to process a new kind of information, which is a quantum information, and the kind of units that we'll use for this processing is called the qubit. And this qubit has some new characteristic compared to the classical information. There is this thing in quantum mechanics. Yes.
Excuse me, Frederic. We still have the same problem with Zoom, which means each 45 minutes we have to switch again. So you have to connect again. So see you
Are you
in 10
using the
seconds.
Zoom of Ljubljana of the university?